Okay, so we blew through Sedimentary Rock Lab and Metamorphic Rock Lab, but I do want to go over the notes briefly that were passed out to you a few weeks ago. So, notes 8.5, sedimentary rock comes from sediments. They formed at the surface of the earth through deposition, compaction, and cementation. There's not a lot of heating, okay, but they do dry out. But it's through the process of deposition, compaction, and cementation. Okay, there's lots of different things that make them stick together, like iron, okay, or silica. But the one that you have to be knowledgeable about in earth science is calcite. Calcite makes sedimentary rocks fizz. Um, Evaporation. So you have deposition of materials. Okay, those are clastic sedimentary rocks. We also have rocks that form from the evaporation of water, and they crystallize. So crystalline rocks, crystalline sedimentary rocks come from the evaporation of water. They're called evaporites. And those rocks would be rock salt, composed of halite, rock gypsum, composed of gypsum, and dolostone, which is composed of dolomite. Okay? Um, Sedimentary rock also forms from the remains of plants, animals. Okay? We have coal comes from plants, oil comes from the dead microbes in swamps, and chalk comes from dead shelled animals a long time ago. And natural gas comes from coal is the solid version of fossil fuel, oil is the liquid version, natural gas is the gas version of fossil fuels. So all these locations are sedimentary rock. That's Guadalupe Mountains and New Mexico. That's Bryce Canyon, sedimentary rock layers. You can see the layers. That's in Bryce Canyon. Okay, that's in Utah. Arches National Park, which is in Utah as well, outside of a city called Moab. And then we get look at this is the Cliff of Moher, which is off the coast of Ireland, and you can see again flat layers of sedimentary rock. Okay, even in Antarctica, they have sedimentary rock. This is the sandstone layers in Antarctica. Okay, and of course the Grand Canyon, big, giant, flat layers of rock, all sedimentary. Okay, we can see them around here. This is Tegonic Falls down near Ithaca. Okay, you can see the flat layers of sedimentary rock back and forth. Also, you can see the V-shaped valley of the waterfall. But that goes along with what we were learning last unit. We have the flat layers of the chalk cliffs of Dover. Again, the continual process here. Sedimentary rocks, flat layers. Okay, so again, they form close to the surface. Temperature and pressure are at a normal temperature and pressure. And right there, most importantly, sedimentary rock is the only rock that has fossils, because if you put fossils in metamorphic rock, they get squeezed and distorted and you wouldn't see them. And if they are magma, well, magma incinerates and burns everything, so you're not going to see it as that. So that is sedimentary rock, okay? Then we have metamorphic rock. Metamorphic rock is what you learned about yesterday in class, Mr. Ward, okay? And that is, we'll zoom into it this way, okay? They're rocks that come from other rocks, either from sediment or from molten rock, and even other metamorphic rocks, okay? Heat and pressure, heat and pressure will make them recrystallize to heavier objects, okay? More dense objects, okay? And metamorphic rocks are foliated. That means there's crystals and layers. Foliation is crystals and layers, okay? Whereas the layers for sedimentary rocks are a similar color. Metamorphic rocks have different colors. See, the metamorphic rock, black and light colored, okay? So, continuing, foliation, crystals and layers. That's what's called dark banding, okay? And we can see those layers. There's two types of metamorphism. We have regional metamorphism and contact. Contact just gives us like a crystalline, non-foliated metamorphic rock. Regional gives us foliated metamorphic rocks you need to know for class, okay? So it comes through heat and pressure. And we're going to spend a little time talking about how metamorphic rocks are created through the presence of magma, through what's called contact metamorphism, okay? So but for regional metamorphism, here you have rock layers. Okay, rock layers are here. There's like shale would be here. And then shale gets pressurized and tilted, becomes slate. Slate becomes phyllite. Phyllite becomes schist, and schist becomes gneiss. And then if you heat it up beyond gneiss, it becomes magma, which is a big giant ball of liquid rock. Again, hot, or I say increasing heat and pressure. So from here, low pressure, low heat, increasing heat and pressure all the way to there. And in a small area around the magma blob there, you're going to get contact metamorphism. And that's what we're going to learn about right now. Contact metamorphism. So contact metamorphism is part of the thing that you did in class. So utilizing the reference tables, I can find out what A is. A is right there. It's limestone because the bricks match up with the limestone. B matches up with shale. You can see that matches up with shale. You should be able to do C and D. But that's not the important skill that you need to learn. You need to know what they turn into when they're exposed to nearby granite or magma. So I'm going to go to my next slide. Okay, so what rock forms at the boundary between A and the granite? A and the granite. So this is limestone. So I got to look on the comments for limestone. Limestone's here, so that means between the limestone and the granite is a zone of marble. Okay, so there's the limestone. Next to the contact metamorphism, this is metamorphism of limestone or dolostone, marble. And that symbol there matches up with, well, what will look like a metamorphic rock symbol. Um, so we have what's happening here. So the contact metamorphism, this is shell, so I look for specifically slate, and slate then becomes shell right there.